Okay, let's get ready for our Unit 6 test. Number 1, as part of his homework, Matt needs to write a transformation rule that would reflect the graph of the square root parent function across the x-axis, make it vertically stretched, and shift it to the quadrant 4. Which of the following equations can he use? Okay, so anytime you want to reflect the graph across the x-axis, we are going to see a negative in the very front. So this one has a negative, this one has a negative, this one has a negative, this one does not. So if it is reflecting across the x-axis, the negative will be in the very front. Okay, next it says that it is going to vertically stretch. So if it vertically stretches, then the number in front is going to be bigger than 1. So don't look at the negative anymore. Is 1/3 bigger than 1? Nope. So it can't be this. Don't look at the negative. Is 2 bigger than 1? Yes. Is 4 bigger than 1? Yes. Okay, so it's one of those two. And it says that it is going to quadrant 4. Okay. So quadrant 4, in case you don't know what your quadrants are. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. They go counterclockwise. So let's just see what these things do. If you have a plus inside, the graph goes left. If you have a minus on the outside, it goes down. So if I was at 0, 0, and I went left 4 and down 3, where would I end up? In quadrant 3. So it can't be B. This one, the minus inside makes it go right. The minus in the back makes it go down. So if I went right 5 and down 2, sure enough, I'd be in quadrant 4. Bing, 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 bing. So this is our winner, chicken dinner. Okay, number 2. We are stating the domain and the range. So domain are x's, range are y's. All right, so right here, our x value is -4. And then the graph goes to the right. So whenever you're doing domain and you're working with x's, you can only think left and right. So since the graph goes to the right, the x's get greater. Okay, do you see anything that does not say that? Well, D and A don't have the equals, and it does equal that -4 there, so I know it's not going to be those guys. Okay, now let's look at range. So range are about your y's. So my y value right here is 0, so it equals a 0. Now with y's, you think up and down. So this graph is going up, 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 so y's are getting greater. And so which one says that? B says it. Now, if it helps you to label this point before you do anything else, then I think that's a good suggestion. So where the graph begins, you go left 4 to get there. So that's your x, because that's what you did left and right. And then you didn't go up, you didn't go down, so your y is a 0. So that's why the domain uses the -4, because that's the x, and the range uses the 0, because that's the y. Okay, number 3. Which inequality is graphed below? Okay, so let's just talk about a few things. It's a dashed line, or a dashed curve, so there will be no equals. So it's either going to be this or it's going to be this. So right now I can get rid of A and B because they have an equals. And then is the shading above or is the shading below? The shading is above. So whenever the shading is above the graph, we use a greater than sign. And so this is our winner. Okay, number 4. We are working with a square root here. So the square root of 25, that comes out nice and pretty. That's just a 5. And then if you have 4 p's, remember with square roots, you're looking for groups of 2 or pairs. And we have 2 groups of 2 or 2 pairs. So 2 p's are going to come out. And then you have 2 t's. And how many groups of 2 or pairs is that? It's 1 pair or 1 group of 2. So 1 t would come out. And so that's my answer. So this is the guy I want. Moving on. Number 5 is working with a cubed root. So this time, I'm going to first see if I can take the cubed root of 256 and get something nice. So I'm going to go to my math button, and I'm going to go to number 4, and I'm going to put 256 in there, and it doesn't come out nice. Okay, so I'm going to do something about that in a second. Before I do that, let's look at the t's. I have 4 t's, and cubed roots, you're looking for groups of 3. Well, how many groups of 3 do we have? We have 1 group of 3, so 1 t comes out, and then this t that doesn't have enough to pair up with is going to be trapped under the cubed root. So let's just see who has the t's right. This one has 1 t out, 1 t in, 1 t out, 1 t in, 1 t out, 1 t in, 1 t out. Well, okay, they all have the t's right. Okay, so now we need to work on the 256. So let's think about our perfect cubes for a minute. We've got 1 times 1 times 1, which is 1, 2 times 2 times 2, which is 8, 3 times 3 times 3, which is 27, 4 times 4 times 4, which is 64, 5 times 5 times 5, which is 125, and I could keep going. 6 times 6 times 6, 216. Anyway, because you can't take the cubed root of 256 and get something nice, I need to find out who's our largest perfect cube that can divide into 256 evenly. So let's see. Since 1 goes into everything, I'm going to ignore that one. Let's try 8. And 8 works, but if our answer can be divided by one of these, we need to keep searching. And 32 can be divided by 8. Okay, so that means there's somebody bigger out there. Let's try to divide by 27. Okay, if you get a decimal, it doesn't work. Let's try 256 divided by 64. And 4 cannot be divided by any of these perfect cubes other than 1, so this is our winner. So 64 goes in there 4 times. So I write this as cubed root of 64 times cubed root of 4. So that's the perfect cube that goes in, and that's how many times it goes in. So now I'm going to clean this up. What is the cubed root of 64? Well, it's 4, because 4 times 4 times 4 makes 64. So this is a 4, and then you can't take the cubed root of 4, so it just stays under the cubed root. So now I know my answer is 8. Now, did you notice what happened with D? Oreo, stop it. D forgot to put the little 3 back on the radical. And since we're dealing with cubed roots, you got to have the little 3 there throughout the problem. Okay, number 6. We are not allowed to have radicals in the denominator. So I need to get rid of this radical. Now, if it had just been a square root of 3 in the denominator, I would have multiplied by square root of 3 over square root of 3. But because the radical is attached to a plus or a minus, I need to multiply by its conjugate. So the conjugate looks exactly the same, but a switch in the sign. So exactly like the denominator, but instead of a minus, a plus. And then I have to multiply in the form of 1, so whatever I put in the denominator, I put in the numerator. This is what I like to call my FFU, my fancy form of 1. Okay, so now I'm going to multiply straight across, straight across. So when I go to multiply my numerators, I'm going to distribute my 5. So 5 times 2 makes 10. And 5 times square root of 3 makes 5 square root of 3. The reason I can't multiply the 5 and the 3 and get 15 is because the 3 is under a square root and the 5 is not. So 5 times square root of 3 is just 5 square root of 3. Okay, that's my numerator. Let's put our division bar. Now let's multiply the denominators. Now, I could FOIL these out or double distribute them, however you like to think of it. But because I know they're conjugates, I know that the inside pieces are going to zero out. So I'm not going to multiply everything. I'm going to multiply only the front numbers and only the back numbers. because the other two are going to zero away. That's what's special about conjugates. So 2 times 2 is 4. And then negative square root of 3 times positive square root of 3 is a negative 3. A negative times a positive is a negative. And anytime you take a square root times itself, that number gets to just slip out from underneath the radical. Now, if you multiplied those and put square root of 9, that's fine. But the square root of 9 is 3. Okay, now let's clean up the denominator. What is 4 minus 3? 1. And then I'm going to recopy my numerator. And 10 plus 5 square root of 3 over 1 is the same thing as 10 plus 5 square root of 3. So our winner is A. Okay, looking at number 7. It wants us to rewrite this with rational exponents. So this is what's called radical form, and it wants us to put it in exponential form. So we're trying to figure out who the exponent is. And it's going to end up being a fraction, and that's why they're using the word rational. Okay, so the way it works is whatever the root is, that's the denominator. And whatever power it's raised to, that's the numerator. So the answer is m to the 3/5. So the root is the denominator, the power is the numerator. Okay. All right, this next one, it's asking which of those would be a correct step in the solution. So we are going to solve this equation and see what the correct step would be. Okay, so first of all, with problems like this, your number one goal is to get the stuff in the parentheses with the exponent by itself before you can do anything with the 1/3. So to get that by itself, how would I get rid of the subtraction of 3? I'd add 3. So I'm going to add 3 to both sides. This zeroes away. 1 plus 3 is 4. And then this left side is going to come down. So bring down the 5z minus 1 raised to the 1/3. Now let's look. Is that any of the answers? Nope. Okay, so we need to keep going. Okay, so to get rid of fraction exponents, we multiply by the reciprocal exponent. So I flip 1/3 over and I get 3 over 1. Well, if I raise that side to the 3 over 1, I have to raise this side to the 3 over 1. But 3 over 1 is the same thing as 3. So when you multiply 1/3 and 3, you just get 1. Shoop, shoop. So all you're left with is 5z minus 1 on the left side. And on the right side, you're left with 4 to the 3rd power. 4 times 4 times 4, which is 64. And looky look, that's answer choice D. From here, it's easy to solve. You would add 1 and then divide by 5. Okay, number 9. This one, we're kind of doing the same, but we have an inequality, so it's going to be a little bit different at the end. So first, I have to get this square root by itself before I can get rid of the square root. Okay, so to get rid of subtraction of 1, I have to do the opposite. So I'm going to add 1 to both sides. So this zeroes out. Shoop. Bring down your square root of 3x plus 6. Bring down your inequality sign. And then 5 plus 1 is 6. Okay, so now I'm ready to get rid of my square root. So to get rid of a square root, we square. And if you square one side, you square the other side. Well, on the left side, the squared and square root cancel each other out. So all you're left with is 3x plus 6. And on the right side, 6 squared, 6 times 6 is 36. Okay, so now what would we do? We would subtract 6 from both sides. If I do that, my 3x drops down. My inequality drops down. And 36 minus 6 makes 30. And then I'm going to divide both sides by 3. And if I divide both sides by 3, I get x greater than or equal to 10. Now, I see this answer over here. Now, that doesn't mean it's the answer, so I need to stop and think for just a little bit. Okay, so I'm going to draw my little number line here. I'm going to put 10 on it. And I'm going to then think about things that could make this problem not work. Well, you can't have negatives under radicals, or under square roots, I should say. You can't have negatives under square roots without entering the imaginary number system. So I know whatever's under here can't be negative, so that means it would either have to be 0 or greater than 0. So I'm going to solve this equation here. You would subtract the 6. That would give you negative 6. You would divide by 3. That would give you negative 2. So this answer I got here, if I shaded everything that was 10 and greater than 10, let's look. Everything that I shaded, are those numbers also greater than or equal to negative 2? Because this is saying for the problem to work, your x values have to be greater than or equal to negative 2. Or are all these answers greater than or equal to negative 2? Yes, they are. So this ends up being my answer, and so my answer is C. Okay, number 10. There's probably a few ways I could do this. I am going to put both of these in exponential form. This one is already in exponential form because it has an exponent, but I'm going to put this one in exponential form. So whatever the denominator is, whatever the root is, that's the denominator. And whatever power it's raised to, that's the numerator. Okay? And then instead of putting a division symbol like this, I'm going to put a division symbol like this. And then I'm just going to recopy this. So now I need to know a rule about my exponents. When you divide, what do you do with exponents? Subtract. When you divide, you have to subtract. So I need to take 5 halves minus a negative 5 halves. 5 halves minus a negative 5 halves. Well, a minus a negative makes addition, and 5 halves plus 5 halves makes 10 halves. So this would be x to the 10 halves, and then I can reduce that. 10 divided by 2 makes 5. So my answer is x to the 5th. And if you needed me to subtract in my calculator, I can do that too. Okay, so I'm going to go alpha y equals, hit enter, 5 on top, arrow down, 2 on bottom, right arrow out of it, minus alpha y equals again, hit enter, and then negative 5, arrow down, 2. And you can see you get a 5, just like we said. Okay, so the problem looked a little scary, but it's really not that bad. Just make them look alike, put them both in exponential form, and then just remember that when you're dividing, you subtract exponents. Okay, moving on. All right, so now we've got some problems with some words. So I know that tends to give students some anxiety, but this really isn't too bad here. All right, so they're saying that velocity is represented by the letter V, M is your mass, and K is your kinetic energy. Okay, the question says, find the velocity. So that means we're going to be solving for V with a mass of 20 and a kinetic energy of 360. Okay, so if the mass is 20, that means I'm going to put 20 into the M. And if the kinetic energy is 360, I'm going to be putting 360 into the K. Okay, so I've got this V equals square root. This says take 2 times K, so I'm going to be taking 2 times my 360 divided by my M, which is 20. Okay, so let's just do the inside part. So I'm going to take 2 times 360, and I'm going to divide by 20. And I get 36. So I have square root of 36, but what is the square root of 36? just a 6. So v equals 6. So that's my velocity. Okay, next one. The appropriate time t in seconds that it takes an object to fall a distance of d feet is given by t equals the square root of d over 16. Okay, I'm going to rewrite that equation so it's all in one line. T equals square root of d over 16. How far will the object fall in 8 seconds? Okay, 8 seconds. Do you think that that is time or distance? It's time. And it's asking how far, which means I'm going to solve for the distance. Okay, so since this is time, the 8 is going to go right there into the t. So this equation is going to say 8 equals square root of d over 16. So now I need to solve this equation for d. So earlier we said to get rid of square roots, you square. And there's nothing outside of the square root to add or subtract away, so I'm ready right now to get rid of my square root. So to get rid of the square root, we square, but if you do it to one side, you have to do it to the other. And so then 8 squared is 64. I'm going to come over here and do that. And over here, the squared and square root cancel, so all you're left with is d over 16. And then to get d by itself, I get rid of division of 16 by multiplying by 16. So I'm going to multiply both sides by 16, and that will be my answer. So 16 times 64. And that makes 1,024 feet. So that is my distance that it will take an object to fall in 8 seconds. Okay, number 13. Oops, not a lot of space to do this one. That's all right. We'll figure it out. Okay, so to get rid of a 4th root, you raise it to the power of 4. To get rid of a square root, you raise it to the power of 2. To get rid of a cubed root, you raise it to the power of 3. And if you do it to one side, you do it to the other side. Well, on the left side, the 4th power and the 4th root cancel, so all you have left is 10k plus 1. And on the right side, I need to figure out what 3 to the 4th is. 3 times 3 times 3 times 3. And I know what it is, but if you don't, you can see it for yourself. And you could always do this number, or you could do this number. Anyway, it's 81. Or you could have multiplied it out by hand. Now, to solve this equation, what would we do now? We would subtract 1. So to get rid of addition of 1, we have to do the opposite and subtract. So the 10k would be all that was left on the left. And on the right side, 81 minus 1 makes 80. And then we would divide by 10. And if you divide by 10, you get 8. Okay, number 14 is asking us to identify the domain. Okay, so I'm going to do it a couple ways. First, I'm going to do it algebraically. So I'm going to take what's under the square root, which is called, I dropped my marker, which is called the radicand. And I talked about this earlier. You can't have a negative under a square root unless you enter the imaginary number system, and I don't want to do that. So if it can't be negative under there, then that means it could be 0, or it could be positive, which would be greater than 0. So if I solve this equation, I'll have my domain. So I'm going to get rid of addition of 16 by subtracting. The 4k drops, your symbol drops. 0 minus 16 is negative 16. And then I divide by 4. And if you divide by 4, you get negative 4. And so, oh, I don't know why I started using k's. Oh my goodness. Come on, Miss Wood. Get your act together. So it's an x, and it should be an x because we're talking about domain, and domain is always about your x's. And so I know my answer right now is A. Now, I could have graphed it, so I'm going to show you that too. Okay, so if I go to my graph, I'm going to put in the square root of 4x plus 16, and I'm going to hit graph. So right here, it looks like the x is beginning at -4, which is what we said, and domain are x's left and right, and this graph goes right, which means x's get greater. I could also look at the table, and you can see the first spot under the error has an x value of -4, so that's why the x is starting there. And you can see that as you go, x's are getting greater, whereas if the x's get smaller, it doesn't work because you get errors. So a few different ways that we can find the domain. Okay, I'm going to stop this video here, and I'm going to finish up the rest of the review in a separate video just so they don't get too lengthy. So that's all for now. Smiley face.